On the 1st of July, 2025, a robotic telescope sitting quietly in the mountains of Chile noticed something strange. It wasn't looking for anything unusual that night. It was doing its normal job, scanning the sky for asteroids that might one day threaten Earth. But buried in the data was a faint 20th magnitude point of light, so dim that most instruments on the planet would have missed it entirely. Within 24 hours, astronomers calculating its path realized something that made them stop what they were doing. This object wasn't orbiting the sun. It wasn't going to loop around and come back like every comet humanity had ever tracked. It was moving in a straight, hyperbolic line, the unmistakable signature of something that didn't belong to our solar system at all, something that had been drifting through interstellar space alone for longer than human civilization has existed, and was now, for a brief moment, passing through our neighborhood. They named it 3I Atlas. It is only the third interstellar object ever confirmed by humanity, and in the years since its discovery, it has done something none of the first two ever did. It has refused to behave the way a normal comet should. This is the story of what scientists have actually found, not rumors, not YouTube speculation. The real, documented, peer-reviewed anomalies that have some of the most respected astronomers on Earth asking a question they don't ask lightly: what if this thing isn't what we think it is? To understand why 3I Atlas matters, you have to understand how rare this kind of discovery is. For all of recorded history, every comet and asteroid we've ever seen has belonged to our solar system. They were born here, they orbit the sun, and their paths are shaped entirely by our star's gravity. Predictable. Familiar. Ours. Then, in 2017, everything changed. A strange, elongated object shot through our solar system on a path that could only be described as foreign. It came from nowhere, sped past the sun, and vanished forever. It was cigar-shaped, tumbling end over end, and it accelerated in a way that defied simple explanation. Astronomers named it Oumuamua, a Hawaiian word roughly meaning scout, or the first messenger to arrive from far away. 2 years later, a second visitor arrived. This one, named Borisov, was far more conventional. A comet with a glowing tail of gas and dust, chemically similar to the comets already familiar to us. It reassured scientists that maybe Oumuamua had simply been an outlier. Then, in the summer of 2025, the third one arrived. And almost immediately it became clear that 3I Atlas was going to be different from both of the visitors that came before it. Unlike Oumuamua, this new object clearly had a coma, the glowing envelope of gas and dust that identifies something as an active comet. That part, at least, seemed normal. But the deeper astronomers looked, the stranger the picture became. The first major clue came from something as simple and as fundamental as water. Every comet in our solar system carries frozen water ice, left over from the earliest days of planetary formation. But not all water is identical. Buried within ordinary water molecules is a rare variant called heavy water, built from an isotope of hydrogen called deuterium. The ratio between ordinary water and heavy water acts almost like a fingerprint, a chemical signature that tells scientists exactly where and under what conditions an object originally formed. When a research team, led by scientists at the University of Michigan, examined the water signature locked inside 3I Atlas, the results didn't match anything in our solar system's own comet population. The deuterium content was significantly higher than researchers expected, a level typically associated with far colder, far more remote environments than anything found near our own sun. In simple terms, the water inside this comet appears to have frozen somewhere colder and darker and more distant than anywhere in our own planetary neighborhood. That single finding told scientists something profound. 3I Atlas didn't just come from another star system. It likely formed in one of the coldest, most isolated regions the galaxy has to offer, possibly in the outer, frozen edges of a planetary disk that existed billions of years before our own sun ignited. Which raises an unsettling question. If this comet formed that long ago, in that kind of environment, just how old is it? Most comets in our solar system are considered ancient by human standards. Frozen relics roughly 4.5 billion years old, the same age as the sun itself. 3I Atlas may be older than that, possibly far older. Because it didn't form around our sun, its age isn't tied to our solar system's 4.5 billion year clock. Based on its chemical composition and the region of the galaxy, it likely originated from. Some researchers studying the object have suggested it could be one of the oldest cometary bodies ever observed by human instruments, a frozen time capsule that predates our entire planetary system. Try to sit with that for a moment. This is a chunk of ice and rock that may have been drifting silently through the emptiness of interstellar space since before Earth existed, before the sun existed. It has been alone in the dark, tumbling through the galaxy for an almost incomprehensible stretch of time, And for a few short months, it happened to drift close enough for us to notice it. And that alone would be enough to make 3I Atlas one of the most important astronomical discoveries of the decade. But then came the observations that made scientists sit up a little straighter. Comets are supposed to be predictable. Once astronomers calculate a comet's trajectory, physics takes over. Gravity is gravity. Unless something is actively pushing or pulling on the object, like gas jets erupting off its surface as it heats near the sun, its path should follow the numbers almost exactly. So when researchers using the powerful ALMA telescope array in Chile tracked 3I Atlas's position with extreme precision, they noticed something odd. The comet had drifted slightly off its predicted course, deviating by several arcseconds from where the math said it should be. On its own, a small trajectory deviation isn't necessarily shocking. Comets frequently experience what's called non-gravitational acceleration, tiny pushes caused by jets of vaporizing ice escaping unevenly from their surface as sunlight heats them. It's a well-understood phenomenon, and it's the leading explanation scientists point to for 3I Atlas's course change. But there was something else. Around the same time as this drift, observers noted that the comet's color had shifted, moving from a reddish hue toward a noticeably deeper blue. Color changes in comets aren't unheard of either. They can happen as the surface composition changes, as different layers of ice and dust are exposed by the heat of the sun. But the combination of an unexpected trajectory shift and a dramatic color change happening in the same window of time was enough to catch the attention of astronomers around the world, and to reignite a question that has followed interstellar objects since Oumuamua first appeared in 2017. What if some of these anomalies aren't just cometary outgassing? This is where the story takes a turn that most mainstream astronomers are uncomfortable with, but one honest reporting can't ignore, because it came from a genuinely credentialed source. Avi Loeb, a Harvard astrophysicist with a long and serious academic career, was among the first scientists to publicly raise a provocative possibility that 3I Atlas's unusual characteristics, its trajectory, its composition, its behavior, could be at least worth considering through the lens of artificial origin. Not necessarily an alien spacecraft in the dramatic science fiction sense, but the possibility that not every interstellar object passing through our solar system is guaranteed to be a purely natural rock. Loeb had made similar arguments about Oumuamua back in 2017, pointing to its strange shape and its unexplained acceleration as reasons to at least entertain non-natural explanations. His willingness to publicly raise these questions made him both one of the most quoted and one of the most controversial figures in the interstellar object debate. With 3I Atlas, that same debate reignited. Some researchers, writing in scientific commentary, laid out both interpretations side by side. The mainstream view, that 3I Atlas is an unusual but entirely natural comet fragment, quite possibly a shard from a disrupted planetary body in another star system. And the far more speculative view that its anomalies deserve closer scrutiny before ruling out anything. It's important to be honest about where the weight of evidence actually sits. NASA, the European Space Agency, and the overwhelming majority of astronomers studying 3I Atlas have been clear and consistent. There is no evidence that this object is artificial, and every observation collected so far is consistent with it being an ancient, unusual, but entirely natural interstellar comet. The trajectory shift lines up with known cometary outgassing behavior. The color change lines up with known surface and composition effects. The extreme age and strange water chemistry make it scientifically fascinating. Not because it might be a spacecraft, but because it's giving us our first real chemical sample from a planetary system that isn't our own. But the fact that a Harvard astrophysicist was willing to raise the alien probe question publicly, and the fact that mainstream science journals felt it necessary to formally address and rebut that hypothesis, tells you something about just how strange this object's behavior has actually been. What makes 3I Atlas's story different from Oumuamua's is something remarkable. This time, humanity actually had the tools in place to watch closely. When Oumuamua raced through our solar system back in 2017, it was discovered so late and moved so fast that only a handful of telescopes managed to catch a glimpse before it disappeared forever, leaving behind more questions than answers. 3I Atlas has been different. Because it was discovered earlier, and because humanity now has a small fleet of spacecraft scattered across the solar system, an unprecedented number of instruments got the chance to study it. NASA's Europa Clipper spacecraft, on its long journey toward Jupiter's icy moon, managed to capture rare ultraviolet observations of 3I Atlas during a period when Earth-based telescopes were blocked by the glare of the sun. The European Space Agency's JWST spacecraft, also headed toward the Jupiter system, captured navigation camera images that revealed the comet actively venting gas and dust, with a clear tail and visible structure inside its glowing coma. The James Webb Space Telescope and the Hubble Space Telescope both turned their instruments toward the object, gathering some of the most detailed spectroscopic data ever collected from an interstellar visitor. Ground-based observatories in Hawaii, Chile, and Australia tracked its progress for months, watching it swing past the orbit of Mars, disappear briefly behind the Sun, and then emerge back into view. It has, without exaggeration, become the most closely observed interstellar object in human history, and every dataset collected has added another piece to a puzzle that is still far from complete. For all that scientists have learned, 3I Atlas is still keeping secrets. Researchers studying its composition say there are entire categories of measurement, the ratios of oxygen isotopes, nitrogen isotopes, and noble gases trapped inside its ice, that would tell us enormously more about exactly where and under what conditions this object originally formed. The problem is that many of these measurements are extremely difficult, if not impossible, to make from Earth or from a distant flyby. They would require getting a spacecraft close enough to take direct samples. That's not entirely out of the question. The European Space Agency has been developing something called the Comet Interceptor mission, a spacecraft designed to do something no mission has ever attempted. Rather than being built for one specific comet, it will launch and then wait quietly in space, parked at a gravitationally stable point, until a suitable long period or interstellar comet is discovered heading through the solar system. Only then will it race out to intercept it. It's unlikely that Comet Interceptor will be ready in time to catch 3I Atlas itself, which is already speeding back out toward interstellar space, never to return. But scientists studying this comet see it as a preview, a dress rehearsal for the day when a future interstellar visitor arrives, and humanity is finally ready to meet it up close. Because if there's one thing 3I Atlas has proven, it's that these encounters are not as rare as we once assumed. 3 interstellar objects in 8 years, each one a fleeting visitor from another star system, passing silently through our neighborhood before vanishing forever back into the dark. It's easy to get swept up in the idea of alien spacecraft and hidden signals. It makes for a great headline, but the real story of 3I Atlas doesn't need embellishment to be extraordinary. This is a piece of another solar system, quite possibly the oldest object human eyes have ever directly studied, that drifted for untold eons through the emptiness between the stars, and briefly, almost accidentally, passed close enough for us to reach out and examine it. Its water tells us about a planetary system that formed in conditions unlike anything near our sun. Its unusual trajectory and shifting color are teaching scientists new lessons about how ancient alien ices behave when they're finally warmed by starlight after billions of years in the cold and the dark. And the sheer intensity of observation it triggered, spacecraft near Jupiter, telescopes on 3 continents, 2 of the most powerful space observatories ever built, shows just how prepared humanity has become for moments like this. We don't need it to be an alien probe for it to be one of the most remarkable objects ever studied. It already is one, simply by being what it actually is. A genuine messenger from another star, carrying chemical secrets from a part of the galaxy we will likely never visit ourselves. Right now, as you're watching this, 3I Atlas is speeding away from us, retracing its long path back out into interstellar space. It will never return. In a few years, it will fade from even our most powerful telescopes, disappearing back into the vast darkness it came from, carrying its secrets with it. Somewhere out there, scattered across the galaxy, there are almost certainly more objects like it, ancient wanderers drifting silently between the stars, waiting for their own brief, accidental encounter with a curious civilization looking up. We got lucky this time. We noticed. We looked closely. And for a few short months, a fragment of another solar system let us peer, however briefly, into a part of the universe we may never see again. The question isn't really whether 3I Atlas is artificial. The real question is, what will we do and how ready will we be the next time something like this comes wandering through?